Hello everyone, this is Mr. Bowman. Myself, Mrs. Gross, and Mrs. Regala will be putting together some lessons for you about the polar coordinate system over the next couple of weeks so that when you come back from spring break, hopefully you will be well rested and healthy and feel like you haven't missed a step. So with that in mind, let's get started. If you look at the middle of my page, you will see a diagram that's labeled with a pole, a polar axis, theta, r, and a point that has polar coordinates r, theta. So what I'd like to do is I would like to connect what you already know about graphing points in a Cartesian or XY coordinate system with how to graph those points using a polar coordinate system. To do that, we're going to draw in the x and the y axis, and you will see that the x and the y axis, which meet at the origin, is also the location for the pole. We call that point the pole in a polar coordinate system, and from that pole extends a ray along the positive x-axis, which we call the polar axis. And to locate points using a polar coordinate system, we have to specify r, which is the directed distance from the pole, and theta, which is a directed angle from the polar axis. So again, r is the directed distance, which I will explain more about the directed in these two terms in just a moment, and theta is the directed angle. Essentially, that means that they have positive and negative directions associated with them. Better understand how to graph points using a polar coordinate system, I'd like to show you some examples. So I'm going to scroll down here to these three examples, and we are going to start with point P, which has polar coordinates 2 pi over 3. So what we do is we start at the pole, we draw in our polar axis for a reference, and we are going to rotate in a directed or a positive direction an angle of 2 pi over 3. So we're going to consider this angle pi over 6, and this angle pi over 4, and this angle pi over 3. So we will start at 0 radians or 0 degrees and rotate to an angle of 2 pi over 3 or 120 degrees and draw in the terminal side of our angle. Now that we've found our directed angle, we are going to move from the pole 2 units in that direction and label that point P. So other than the dot at point P, all this other stuff is extraneous information which you can now remove if you like, and we have now located point P. Example B, you will notice, has a directed distance of -1 and a directed angle of 3 pi over 4. So again, we're going to start at the pole. We're going to draw in our polar axis. We are going to rotate to an angle of 3 pi over 4 or 135 degrees and stop there, draw in our terminal side, but then instead of moving 1 in the direction of 3 pi over 4, we're going to move 1 in the opposite direction because of the negative directed distance, and we're going to label that point Q. And finally, a third example where we have a positive directed distance but a negative directed angle. So again, starting at the pole, drawing in our polar axis, rotating backward or in a negative direction of 120 degrees, and then from the pole we are going to move out 3 units in that direction and label that point R. One notable difference between polar coordinate systems and rectangular coordinate systems is that we can specify a point P, for example, in a polar coordinate system using an infinite number of directed distances and directed angles. And I'd like to illustrate a few of those with you right now. So in our example, we're going to plot the point P, which has a directed distance of 3 and a directed angle of pi over 3. So I am going to label the angle of pi over 3, and I am going to go to the pole, draw in my polar axis, and I am going to rotate to that directed angle of pi over 3, draw in the terminal side, and then move 3 units in that direction to label point P. Well, if we were to specify an angle that was 180 degrees opposite that, we could use a directed distance of -3. Or another thing that we could do is we could continue on rotating around the circle until we get back to that terminal side of the directed angle. And as long as the angles that we specify are coterminal with pi over 3, then we can use a directed distance of +3. If they're 180 degrees opposite or pi radians opposite the directed angle of pi over 3, we would have to use a negative directed distance. So some examples of points that are exactly the same location as point P, or another way of putting it is other ways of labeling point P would be the following. Let's say we want to use a negative directed distance, then we would have to be 180 degrees opposite point P. So for example, if we were to add pi radians to our directed angle of pi over 3, we would have pi over 3 plus 3 pi over 3, which would be 4 pi over 3. That would be one way of specifying it. Another way we could specify it is to say we are going to subtract pi radians. So we would use a directed distance of -3, but pi over 3 minus 3 pi over 3 would be -2 pi over 3. Or if we wanted to, we could use a directed distance of +3 and add any multiple of 2 pi over 3, or subtract any multiple of 2 pi from pi over 3. So an example of that would be pi over 3 plus 6 pi over 3, or 7 pi over 3. Or if we wanted to subtract, we could use 3 and our directed angle of pi over 3 minus 6 pi over 3 would be -5 pi over 3.